Now let's focus on the notion of const in C++. It's a keyword you already know from C, and unfortunately, I guess you haven't used it a lot. The semantics of const in C were good, but in some cases, it wasn't really like it should have been, which is why students tend not to use const the way it should be, or not at all. Unfortunately, const is something extraordinary because it will allow you to make a variable constant, therefore have a constant. You might not realize it yet because you're new to programming, but that's the difference between a program that blows up and one that doesn't in the long term. You'll have the opportunity to examine the issue further when you start functional programming, as you'll be working in a constant world, and you'll see that it makes things a lot easier. And in a language as complex and risky as C++, trying to work with as many constants as possible guarantees you that your program will work fine in the end. For now, I understand that you don't really realize. If you don't feel confident yet, you won't use many constants, but a lot more variables. But time will go by, and I'm urging you to try and make your code as constant as possible. It will only make it better. So const in C++ is a marvel. There is, of course, the ability to make a variable constant, but we'll see that there are extra uses. Let's discover the code together, more particularly the declaration of our good old sample class we are getting familiar with, to which I added two attributes. Here we have a const attribute, a float, that I'd like to use as a constant, and an integer that is useless for now. We can see that the constructor will accept a constant float that I'll be able to initialize my const. Remember in C, when we wanted to define a new constant, we couldn't just write int const a, then a equals 42, semicolon. It wouldn't compile. Why? Because a equals 42 colon is an assignment, and the definition you can't make assignments with constants. So with only to assign a value to a constant is by initializing the constant to this value. And the initialization in C consisted in writing on the same line the declaration, then equals, and the original initialization. So we had something like int const a equals 42 semicolon. This would compile, and it was the only way to have a constant. I'm now in the context of a class, with all this remaining true, but the following problematic. I would like my constant, pi for example, to be initialized with a value passed to my constructor. So at this moment, I don't know the value of pi. We all know it's 3.14, but let's say I'd like to specify the precision of this value. This is not possible currently. Remember, I told you earlier that initialization lists would allow us to do more than just initializing members. Since it's about initialization, you probably know where I'm going. Indeed, this process will help us initialize a constant in a class. The code is as follows. You already know the syntax here, my pi attribute that is a constant. I'll be able to initialize it to the f value passed to my constructor. I want to insist on the vocabulary. Here, I'm not assigning the f value to my pi attribute. I'm initializing my pi attribute to the f value. These are different things. You can see that I also decided to initialize my integer attribute, apparently useless so far, to the value 42. So I have my constant. I know that no matter what instance I create, I'll have an integer which value will be 42. Here it has little interest, but we'll see in a moment why I did this. I compile, I run it, and you'll see that it works. Before doing this compilation and execution, I'd like to show you a second use of const. You might have noticed in the code, and you're wondering what const was doing there. I think that's the most important use of const in C++. You've seen on the left in the declaration of my bar bracket member function. After the bracket of my parameters and before the semicolon at the end of my declaration, I used a little const keyword. It's a syntax you've probably seen, and that must look odd to you. What does const mean when placed here? Let's go back to the definition of our member function. We can notice after the closing bracket, the const keyword before the opening curly brace. In C++, when you place the const keyword between the closing bracket and either the semicolon for the declaration or the closing curly brace for the definition, you're telling the compiler that this member function won't alter the current instance. It means that I won't have anywhere in the code an assignation like this is greater than an attribute equal a value. If you write this, it won't compile. Why is it relevant? Because you probably have a state in your object at a particular moment. It might come back later to extend your class and add a feature. And you think, here I'll need to update my attribute. So you update it, but you forgot that your class is complex and you just broke the way it worked. This attribute wasn't supposed to be changed at the moment of the code, but you forgot. You compile, you run it, and it blows up. You spend a couple hours debugging to find out why. But when you first wrote your class, it appeared obvious and logical to you that the instance of the class should never be altered. So you were smart enough to place the const keyword when declaring and defining. To show that the code of this member function should never be changed in the current instance of your class, that's a reflex I'd like you to have as soon as possible. Because that will be the difference between good and bad future C++ developers. If you write a member function that doesn't change the instance of your class, please declare it and define it as const. Experience will prove me right. I encourage you to check on the internet to find out why exactly. Talk about it with yours around you, but it really is something central in C++ and a good practice in programming in general. Now that I've showed you all this, we can start compiling. Very simple, and run it. Here it works perfectly. However, take a look. Now imagine, and that's when my little QD attribute comes into play, that I decide to write this is greater than QD equals 0. My attribute isn't const, so in theory nothing stops me from doing this assignation. But since I declared and defined my member function as const, I can't change the current instance. Therefore, I can't change this. So I can't change this is greater than QD. To make sure of this, let's compile. We can see here, G++ is telling me, your instance is read-only. You can't do this assignment, and it won't compile. This will save your life and hours of debugging. So get used to it as soon as possible. The more your code will be const and read-only, the more your code will be robust on the long term. I see you for the next part.